For the first time in more than 50 years, NASA is preparing to send a crewed spacecraft toward the Moon. This mission, known as Artemis II, represents a pivotal moment in modern space exploration. It serves as the second flight in the Artemis program and the first to carry a human crew. To understand the significance of Artemis II, we must look back at the historical context of lunar travel. The last time humans ventured to the Moon was in 1972, during the Apollo 17 mission. While the Apollo era focused on a series of landings to demonstrate technical capability, the Artemis program is designed for a different era of exploration. Artemis II is not a landing mission. Instead, it is a crewed test flight intended to prove that the systems required for deep space travel are safe and functional for humans. It follows the success of Artemis I, which was an uncrewed mission that traveled 1.4 million miles over 25 days in 2022 to test the initial performance of the rocket and spacecraft. With Artemis II, NASA aims to transition from automated testing to human-operated flight. This mission will carry 4 astronauts farther from Earth than any human has traveled in decades, setting the stage for a long-term presence on the Moon and eventually missions to Mars. Mission objective and intention. The primary objective of Artemis II is to verify that the Orion spacecraft's life support systems and manual controls operate correctly with humans on board. Because this is the first time a crew will fly on the Space Launch System, or SLS, and the Orion capsule, the mission is essentially a rigorous flight test. NASA's intention with this specific flight is to test deep space capabilities rather than the lunar surface itself. This includes evaluating how the spacecraft handles the radiation environment of deep space and how the crew can interact with the vehicle during complex maneuvers. The mission is a necessary bridge to Artemis III, which is intended to be the first mission of the program to land humans on the lunar surface. By conducting a lunar flyby first, NASA can ensure that every component of the spacecraft, from the communication networks to the heat shield, is ready for the more complex demands of a landing mission. Beyond the Moon, Artemis II is part of a broader strategy. NASA views the Moon as a stepping stone for future exploration. The data gathered during this 10-day journey will inform how the agency designs and operates future missions to Mars, where crews will need to survive in deep space for much longer periods. The mission will be guided by a crew of 4 astronauts, selected for their diverse expertise and ability to work under high-pressure conditions. These 4 individuals have undergone nearly 3 years of intense training. Their preparation includes studying the Orion spacecraft in detail, running through thousands of simulations, and learning geology to identify lunar features from orbit. They have also focused on the psychological aspects of teamwork, working with coaches to ensure they can function effectively while locked in a confined space millions of kilometers from home. The vehicle that will carry them is the Orion spacecraft, which the crew has officially named Integrity. Orion is a modern capsule that, while resembling the Apollo command module on the outside, is significantly more advanced. It features 330 cubic feet of living space, about 60% more than Apollo, and uses a lighter, stronger aluminum alloy for its structure. Orion is equipped with a new toilet system called the Universal Waste Management System, which is a significant technical upgrade over the methods used during the Apollo missions. The spacecraft also features 4 23-foot-long solar panels to provide power during the journey. To reach the Moon, Orion will be launched by the Space Launch System, or SLS. The SLS is currently the most powerful rocket NASA has ever flown, producing approximately 4 million kilograms of thrust. This is roughly 450 metric tons more thrust than the Saturn V rocket used during the 1960s and 70s. The SLS consists of a massive orange core stage powered by 4 RS-25 engines and 2 solid rocket boosters attached to the sides. The Artemis II mission is expected to last approximately 10 days. The timeline begins on launch day, where the crew will suit up and board the spacecraft approximately 8 hours before liftoff. Once the SLS engines ignite, the rocket will climb into the sky, performing an automated roll to begin its journey across Earth's orbit. After reaching Earth orbit, the crew will perform an initial checkout of all systems. One of the first major maneuvers is an apogee raise burn, which will boost the spacecraft into a high Earth orbit about 70,000 kilometers above the planet. At this distance, the Earth will appear roughly the size of a basketball held at arm's length. During this phase, the crew will conduct a proximity operations demonstration. The pilot, Victor Glover, will take manual control of Orion to fly near the discarded upper stage of the rocket. This test is vital for practicing the docking maneuvers that will be required on future missions when Orion must connect with a lunar lander. Once these Earth orbit tests are complete, Orion will perform the trans-lunar injection burn, a maneuver that sends the spacecraft toward the Moon. This journey takes approximately 4 days. As they reach the Moon, the crew will perform a lunar flyby, passing around the far side. For about 45 minutes during this flyby, the crew will be in a communication blackout as the Moon blocks radio signals to Earth. During this time, they will study craters and mountains from a vantage point no human has visited in over half a century. Earth's gravity will then naturally pull the spacecraft back toward home. The final critical phase is re-entry. Orion will hit the Earth's atmosphere at speeds of 40,000 kilometers per hour, generating temperatures near 2,760 degrees Celsius. The spacecraft will use a series of parachutes to slow down before splashing down in the Pacific Ocean, where recovery teams will be waiting. The wet dress rehearsal process. Before the actual launch can take place, the SLS rocket and Orion spacecraft must undergo a wet dress rehearsal. This is a comprehensive test where the launch teams practice the entire countdown and fueling process at Launch Pad 39B at the Kennedy Space Center. During a wet dress rehearsal, the rocket is fueled with real liquid propellant, a process known as tanking. This is a critical step because handling cryogenic fuels is complex and dangerous. The systems must be tested to ensure there are no leaks and that the fuel lines can maintain the necessary temperatures and pressures. Engineers also use this time to check the ground infrastructure, such as the purge lines that keep the rocket's internal cavities clear of unwanted gases. The rehearsal allows the team to verify that the flight software and ground control systems are communicating perfectly. This test provides the final data needed to ensure the vehicle and the launch pad are ready for a crewed flight. Current condition and updates. As of early 2026, NASA has adjusted the schedule for Artemis II based on several factors, primarily safety and weather. The wet dress rehearsal was recently targeted for February 2, 2026, after being delayed by unfavorable weather conditions. Because the rehearsal was shifted, the earliest possible launch date was moved to no earlier than February 8, 2026. NASA has identified several other potential launch windows in March and April of 2026 should further delays occur. A significant area of focus during this preparation phase has been the spacecraft's heat shield. After the uncrewed Artemis I mission, engineers discovered that the heat shield material had cracked and charred unevenly in some areas. This led to an 18-month investigation into the root cause. Some former NASA scientists and engineers have expressed concerns about the heat shield, suggesting that the risks might be too high for a crewed mission. However, NASA leadership has stated that they have identified the cause of the issue, which related to the specific skip re-entry path taken by Artemis I, and have modified the return course for Artemis II to reduce high heat exposure. NASA Administrator Jared Isaacman has emphasized that the agency follows a data-driven approach, prioritizing the safety of the crew over the speed of the launch. The final launch date will only be confirmed once the results of the wet dress rehearsal are analyzed and the safety of the redesigned re-entry profile is fully verified. What comes after Artemis II? Artemis II is a foundational step in a much larger plan for human exploration. If the mission is successful, it will clear the way for Artemis III. While Artemis II focuses on the journey, Artemis III will focus on the destination, aiming to land the first woman and the next man on the lunar surface. In the long term, NASA plans to establish a sustainable human presence on and around the Moon. This includes the development of the Gateway, a small space station that will orbit the Moon and serve as a hub for lunar surface missions. The ultimate goal of the Artemis program is to use the Moon as a laboratory for Mars exploration. By learning how to live and work on another world, NASA can prepare for the much longer journey to the Red Planet. Artemis II is the first time humans will enter the environment where these future missions will take place. Artemis II is a necessary and practical step in humanity's return to deep space. By sending a crew to orbit the moon, NASA can test the essential technologies like the SLS rocket, the Orion capsule, and the deep space communication networks that will sustain life on future missions. This mission is not about repeating the achievements of the past, but about building a sustainable framework for the future. It acknowledges the inherent risks of spaceflight while using rigorous testing and data analysis to mitigate those risks as much as possible. As the crew prepares for their 10-day journey, the focus remains on the primary goal, a safe and successful test of the systems that will eventually take humans back to the lunar surface and beyond. Artemis II marks a new era where the moon is no longer just a destination, but a gateway to the rest of the solar system.
If you enjoy deep-dive science documentaries like this, focused on real data, real mysteries, and the edges of human knowledge, consider subscribing. New videos explore the universe where certainty ends and discovery begins. And let us know in the comments what you think. Thanks for watching.